This is an algebra video about solving modular equations. First of all, just a little bit of vocab. Modulus can sometimes be called absolute value, and we encounter it in algebra and also in other topics like complex numbers. So let's have a look at an example of how to solve a modular equation. So in this example, we want to solve for x, and the absolute value of x plus 1 equals 4, or we can say modulus x plus 1 equals 4. There are two different approaches we can take to solving this equation. Option 1 is that we can square both sides of the equation. So instead of having the modulus of x plus 1 equals to 4, I've got modulus x plus 1 squared equals to 4 squared. When I choose this approach, then I effectively just square out the left-hand side as if it was a regular set of brackets. I end up with x squared plus 2x plus 1 equals to 16, which clearly is resolving into a quadratic. I just need it to be equals to 0 before I can solve. And I can achieve that by bringing the 16 across and then just tidying up slightly. So I've got x squared plus 2x minus 15 equals to 0. I can then factorize the quadratic and solve. So pause the video here and do that and then check and see if you were correct. So in this case, my factors are x plus 5 times x minus 3 equals to 0. And I get two solutions, x equals minus 5 and x equals to 3. I personally quite like this approach because option 1 here, where I square both sides, it'll work for a question of this type. It'll work for a slightly more complicated modulus equation question, and it'll work for modulus inequalities also. So it's a pretty safe option. Option 2 is probably the quicker approach for this particular type of question, where it's really simple and I have one absolute value or modulus statement on the left equals to a number value. You might remember that these modulus lines or absolute value lines mean that the positive version of the solution of x plus 1 equals to 4. So what I have in between the lines, x plus 1 might be 4, or it might be negative 4. And I can use that to use option 2. So I can say that x plus 1 equals 4, or x plus 1 equals negative 4, and then it's pretty simple to solve. So my first solution here will be x equals 3, and my second solution is negative 5. Now, you don't need to go doing the question in two different ways. Just pick one of the options and go with it. You can see here in a question like this is a really quick way and easy way of getting your answer. Option 1, like I said, is useful because it'll work in a variety of different scenarios. So here I have example 2, and this looks a little bit different from the previous example in that I have absolute value lines on both sides of my equation. In this particular type of question, option 1 is a good approach. So I'm going to square both sides of my equation, and then I'll expand the squaring on both sides. So I get x squared plus 4x plus 4 equals x squared plus 6x plus 9. Conveniently in this case, the x squareds cancel out, and I can tidy up to 4x minus 6x equals 9 minus 4, and then I'll just solve for x. You can still use approach 2 or option 2 when you're dealing with this question, example 2, by taking the positive version of the right-hand side of the equation, first of all, and then for your second equation, taking the negative form of the right-hand side of the equation. It's a little bit messier, I find, so I would suggest from this point on sticking with this approach. And here's our third example. You'll notice in this case that I have a number value on the outside of the modulus multiplying by modulus x plus 1. I'm still going to take the same approach as before. I'm going to square both sides of my equation. I just need to be sure that I square all of the left-hand side. So it's not just the absolute value that I'm squaring, but the entire left-hand side of the equation. When I expand this square, I will square the number, and I will square the absolute value, and I will multiply these together. So I'll have 4 times x squared plus 2x plus 1 equals x squared plus 4x plus 4. And now I want to just do a little bit of tidying up and resolve it into a quadratic on the left-hand side equals to 0 so I can solve. So pause the video here and try that yourself. So I've multiplied on the left-hand side. The 4's cancel out neatly. I bring everything to the left and I tidy up, and then I want to solve for x, so I'm going to have to factorize out the x this time, and I'll let each factor equal to 0 and solve, and that will give me two results in this case for x.